Hello, students. Thank you for joining me. Today, we're going to be working on transformations of absolute value functions. My name is Mr. Nguyen, and I am going to be doing your IXL practice with you today. So, before we begin, though, let's review the rules for transformations really quick. We have two different types of shifts. So these would be the movements or translations of your graph up and down, left and right. So the horizontal one is the one where you go left and right. Now there is a negative there to indicate that it's actually opposite of what you think it is. So if you're moving to the graph to the right, it's actually going to be subtracting the value. And if you're moving to the left, it's actually adding the value, right? So it's opposite of what you think. And notice that it's written inside the parentheses. That means it is affecting the x axis or the x value of your function. So whatever function it is, because we are working with absolute value function today, all of the horizontal shifts are going to be happening inside the absolute value bars. Okay, so keep that in mind. The vertical shifts indicate the translation or movement up and down the graph. And notice it's a plus K, which means, which indicates to you that the movement is normal, like what you think it would be. If you're going up, you would be adding a value. If you're going down, you will be subtracting the value. And you notice it happening outside of that function, right? Which means it's affecting the Y value of that function, okay? Next one, we have two different kinds of reflections. Technically, for absolute value function, if you are reflecting over the y-axis, you really get the same graph. Because if you notice, the negative sign is inside the absolute value bar. Well, it's an absolute value function. If you put a negative sign in there, it's going to become positive, right? So the reflection over the y-axis really doesn't make that a difference in the graph, right? However, reflection over the x-axis will make the graph look different because it is now flipping the graph over the x-axis. So as you can see, the negative sign is actually in front of the function, outside the absolute value bars. Okay. Then we have horizontal stretch and compression. Again, horizontal indicates the left and right direction. So stretch means pulling the graph apart, and compress means pushing it in, right? So as you can see, it's affecting the x-axis. If you are compressing, you're pushing the graph in, you're actually dividing by a value there. And if you're stretching, you're pulling it out, you are multiplying. So I mean, I'm gonna. The rule is kind of hard to see, but I'm gonna walk you through it if we run into those problems. Okay, vertical compression is up and down, so we're pulling it up and down. This is probably the most popular case anyway, when it's happening outside of your function, and it's affecting the y value. So you multiply by some number to pull it apart. You are dividing by some number to push it down, right, to make it sort of wider. You're gonna see those rules when we do the practice. It's kind of hard to explain without accompany it by some real values. Okay, but I will try my best to help you see what it really looks like. Okay. All right. With that being said, let us begin. All right, let's do this. Absolute value function has a parent function. Let me get my web paint on, and today we're going to try this nice bright color, cyan. Here's my pen. Oh, by the way, I have a new stylus, so let's see if it works as well as I hope it will. I've never used it before, so because my handwriting is really terrible. I'm using my mouse pad. So I'm hoping the stylus is gonna help my handwriting. Anyway, okay. Let's see what we're doing here. We are translating, right? So we're moving. We're shifting 2 units up Okay, so again, up is vertical. So as you can see over here, I'm going to go back. Up is a vertical shift, so I'm just adding some number at the end. And because I am moving up, I am adding 2. Okay, so let's go back over here and say, okay, we are going to add 2. So let me select my mouse cursor there. The absolute value function. So here's the form. The A value is for the stretch and compress. The H value is for moving left and right. The K value is for moving up and down. And so we are moving up, so I am going to keep everything else unchanged. So there's no A, there's no H. I'm just going to put an X there, and I'm adding 2. That is the only change, right? And that is my new function, g of x. Submit. Yeah, so an easy one out of the way. We got 12 points there. Let's try another one. This one we're moving to the right. Okay, so review really quick. Moving to the right is a horizontal shift. And again, it is the opposite of what we think it's going to be. And it happens inside the absolute value. So let's go back over here. So it's happening inside. So x and then something else, right? So we're moving to the right. We're moving to the right, right? So 2 units to the right. That means we are going to be subtracting, right? So we are going to be subtracting 2 units, okay? And there's nothing else happening, so we leave everything else alone. We don't put anything in there. Submit. Cool, cool, cool. Okay, this one reflection across the x-axis. So we are flipping it. All right, so let me review really quick. Over the x-axis, the sign, the negative sign is outside of the function, right? Okay, so and that's all I have to do. So a negative sign outside of the function, and then my absolute value function. Bam. Okay, this one is a combination of moving to the left and moving down. So guys, when you are doing this, make sure you highlighting keywords. Translation mean moving or shifting. 5 units to the left indicates that it's going to happen inside the absolute values. And then 5 units down mean it's going to happen outside. This is opposite. This is not opposite. Okay, let's do that really quick. So here's my original parent function. Okay, now let's apply some translation. So I'm moving to the left. That means I am adding because it's opposite of what I think it is, right? And now I'm moving down, which happened outside of the function. So I am going to subtract 5. Okay, I need some water. Okay, let's submit this. Awesome. Okay, if it repeats, yeah, which it is repeating. So I will do one more just so you guys really get a hang of this. And then if it repeats again, I'm going to skip, okay? So I can see, we can see different types of problem. Okay, here we go. 4 left and 6 up. Okay, so we are moving 4. So translation again, 4 to the left and 6 units up. Okay, so left mean inside, up, outside. Okay. So always start with the original parent function, which is x. And then now we're going to apply inside, going to the left. So add 4. Remember, opposite. And then outside, moving up 6. So we're adding 6. And you are done. It. Awesome. Okay, it's repeating. So I'm going to jump level. Jump level, jump level. We're at 65. Ooh, we get a graph now. Uh-oh, we're doing it from the graph. So let me zoom out a little bit so you can see the whole entire graph. I hope this is not too small for you. Move this box out of the way. And moving that up a little bit. Okay, so let's see here. Remember our parent function, it's okay. Let me graph the parent function so you can see what it is. It's actually pretty easy. It's kind of like a line, and then it bent the other way to make a V. Okay, so y equals absolute value x. There's your V shape. Okay, so guys, this is Desmos. You can use Desmos to You can use Desmos to do a lot of your graphing. It's really nice. You can zoom in and out like that. Very convenient. Move the graph around. This is so much better than your graphing calculator because you can't do this on your graphing calculator. All right. Anyway, so as you can see here, the slope of your absolute value function is actually the same as the slope of a linear equation. So it's up 1 over 1, up 1 over 1, up 1 over 1. So rise 1, run 1, rise 1, run 1, rise 1, run 1, right? And then here, rise 1, run, rise, run, rise, run. So it's counting the slope will help you determine whether it's got wider or skinnier. So it's going to help you determine this a value right here, this a value. It's going to help you determine that a value by just looking at the slope of the graph. Okay, so let's take a look at this one. Obviously this is a reflection and it happens on the x-axis, so I know it's happening outside of the absolute value, so I need to put the negative sign down first and then the function. Now, I want to know if there's any, we know it's not moving left or right or up and down because it stays in the origin. The last thing I need to check is this A value. I want to know if it got wider or skinnier, right? Because of some kind of stretch or compress. So I need to check that. And to check that value, all I have to do is to count the slope. So if you look at the slope of this line, it's still rise 1, run 1, rise 1, run 1. So there is no change in my A value. So this is all that there is to this transformation. So I am done. I hit submit and voila. All right, let me show you some more. All right, so this one obviously moved to the left, right? It does not reflect. All right, so I'm going down all the list of my transformation and check them, right? So I'm checking to see if it's moving left and right, and I said it's moving to the left. Obviously, it's not moving up and down because it's still on the y-axis, the x-axis, and I know it didn't reflect because my graph it's still pointing upward that way. And then the last thing I check is the compress or stretch, right? And that is checking the slope. Okay, so let's put in what we already know. We already know that it moved left 2 units. So moving left, it's inside, right? So it's going to be x, and it's opposite of what we think, so it's going to be plus 2. And we know it doesn't move up and down, so we don't need to add anything or subtract anything at the end. However, we do need to check the front. There is no negative sign because I'm not reflecting, but I do need to check this A value, okay? And that is easy. Check the slope. So look at the slope here. Is it still rise 1, run 1, rise 1, run 1, rise 1, run 1? If it is rise 1, run 1, then your slope is not changing. The parent function slope is still the same. So this is all that there is. This is it. I'm done. Okay, I just move left 2. That's it. Very cool. All right, this is the same. So I'm going to skip. I'm going to jump level. Let's just move to the left. All right, how do I know that? Well, I have experience. Okay, let's try this one. This one looks like there's multiple transformation because obviously it flipped and it moved to the right. I don't know if it got any bigger or smaller, but we can check that as well. We know it didn't move up and down, right? So let's put in what we know. We know it reflected, so we have to put the negative in front. And then we know that it moved to the right, so we have to do x minus. Remember, it has to be minus. And it looks like it moved to the right 9 units, so it's going to be minus 9. And we don't have to add or subtract anything at the end. However, we do have to check the number A to see if there's any changes to A. If there's not any changes, we leave that negative alone. If there is some changes, then we put a number in after that negative, okay? So let's check the slope. Is it still rise 1, run 1? Rise 1, run 1, rise 1, run 1, rise 1, run 1. Yes. So there is no changes to A, and I am done with that transformation. So I'm going to hit submit. Awesome. Oh, this one looks definitely different from the parent, okay? So there is actually some kind of pull or push on these things, right? So we'll find out what it actually is, okay? All right. So let's take a look at, let's go down the list. There is moving to the right 2 units. There is no reflection. There's no moving up or down. However, it looks like it got wider, right? And how much wider will be determined by the slope of this line. So I'm going to show you how to do that real quick. Let's put in what we know so far. We know it moved to the right 2 units. So x minus 2 on the inside, right? Left and right happens inside. And then there's nothing outside because we're not moving up and down. There is an a value that changes, right? So let's count the slope. So as you can see here, you always start here and then you go and you see, oh, here's another point I could count, right? Don't pick anything in between the grid where you don't know where exactly that is. Pick the point where you actually know where it is. It's on the grid right here, this point right here. Okay, so and then this point right here. Okay, so I know the location of these points. So I'm gonna count my my slope. So rise one, run 1, 2, 3, 4. Um, so rise one, run four. 1, 2, 3, 4. So rise one, run four, which means my slope is 1/4. So I'm going to type in 1/4 in front of that function. 1 divided by 4. And I think I can type it like that. I don't know. I better use the fraction bar because I know IXL sometimes can get very picky. And 1/4. So make sure you use the fraction thingy. All right. Let's submit and hope that that's correct. Whew, yay, we did it. Okay. Let's look at this one. This one looks, apparently, this is obvious. It moved to the left, so that's how much we know so far. It looks like it got skinnier a little bit, but we can find that out. There's no reflection and no moving up and down. Okay? So, do you see how every time I check for those transformations? So I make sure that I check them. All right, start with the parent function, x right here. So I know it moved to the left 3 units, and that's going to happen inside, and I'm going to be opposite, so I'm adding 3. There is no moving outside, that is up and down. There's no reflection, so I don't have to worry about the negative sign. However, I do need to check the a value. The a value here can be checked by your slope. So I'm gonna pick 2 points on this line right here. I always pick the vertex, and then I move along the line to see if there's a grid where I can actually. There is one? Is 4 one of them? Let me go. Yeah, it's. Oh, is that a good one? Oh, I can't find it. Oh, here's a good one. That's a good one right there. That's a good point. Here, this one's a. Uh, yeah, that's a good one. So what is that? Oh God, I gotta count a lot. 1, 2, 3, 4, 5, 6, 7, 8, 9. That is 9 unit. And then go over 1, 2, 3, 4, 5, 6, 7. 9/7. Rise 9, run 7. And the reason I picked that was because none of these it's exactly on the grid, so I don't know what it is. This one is. So 9/7. So I'm gonna type in 9/7 and see what it does. 9/7. That's my slope. Okay? And I'm hoping that it's correct. Whew! We are good. Okay, we're in the challenge zone. It's gonna get harder, guys. Well, I don't know. Looks like it just reflected and got skinnier. It didn't move anywhere. So there's no movement. So I'm just gonna put in my X here. There is no moving, so there's no change in inside or outside. However, there is a negative sign because it's reflected. And I'm going to count my slope because I need to know my a value, right? So what is the slope? So I'm going to start here and I'm going to pick another point where oh, here's a good point. So let's count that. So 1, 2, 3, 4, 5. 1, 2, 3. So run 5. Rise 5, run 3. So rise 5, run 3. I already have the negative, so I don't need to worry about the negative, right? The reflection took care of the negative. So all I have to do is worry about the rise and the run of my slope. right? So what did I say? Rice 5, run 3. So I'm going to put 5 over 3 in. Rise 5, oops, that's not 5. Rise 5, run 3. Okay, and hit submit. Yay. Okay, guys, it looks like it's going to be just like this for the rest of the practice. So I'm going to stop here. You guys try this on your own. And if you want to stop at 90 something, that's fine. That's a good, smart score anyway. But if you want to challenge yourself and get all the way to 100, do that, okay? Just for the sake of it. So but anyway, send me your question if you get stuck. Thank you for joining me, and I will see you in the next video. Bye bye.